Brilliant. Thank you so much. You've heard me speak plenty tonight. I've no interest in speaking anymore. I really want to see some people on mic now ask some questions. Christoph's still here. Richard's still here. Obviously, Mahanti's still here. I'm just clicking through to see who else we've got from earlier. We can find that out. Niraj, are you there? Do you want to unmic? Ask a question?
Yeah. Hi. Yeah. So it was very interesting presentation, Mohanty. So just want to check, while you have given a lot of use cases, basically the masses don't really, still understand what AI is all about, and they still think of it as a black box. And if they are not comfortable in knowing how the decision was made, they are eventually not comfortable with the AI. So how this situation can be handled?
That's a good question. Again, that's a question I think about a lot. Because if we want to enable many people to use it, first they need to be comfortable with it. So it is true that many people think of AI as a black box, but also not true at the same time, because many people think AI as a black box which is not accessible. So imagine a CTO of a really smart CTO of a traditional company who has no experience in AI. This person, when they have to think, okay, we have to build a product around AI, let's say understanding satellite imagery. Right now, they don't feel that this is something that can be probably done in-house, or you can take the first steps. Right now, they're like, okay, we need to kind of find these AI wizards somewhere who can come in and do it for us. So the first step there is to actually acknowledge that it's okay if these are black boxes. But can we enable you to use these black boxes, even if you do not know how it works internally? You just know that this is this black box, like this black function where you pass in this image and it gives you annotations of where the buildings are and so on and so forth. So the first step would be to kind of make a lot of people comfortable in using these black boxes. And at the same time, we have to also convince a much larger team of engineers that it's okay. It's okay to take a step back and open these black boxes and tinker around and see what happens. You cannot break anything, and it's a safe space in here. So looking at both these things at the same time, at the same different levels, will basically, somehow help us push, make AI less of a black box and more of like a everyday tool that everyone uses.
Thank you so much. Alex, do you want to ask your question to Richard?
Yes, I'm here.
Sorry, find the mute button. Yeah, no, very interesting talk, and obviously very large amounts of data. What I was interested in from your perspective, Richard, and possibly from other people, did you find anything analogous to Mohanty's bouncing skeleton? Anything that you might not have expected by doing large data analysis in an intelligent way, in inverted commas? Did you find anything that was really not something that humans would have expected to be there?
Well, we did see a few things. For instance, when the schools were closed down, in Spain, many families have second houses, because of their families, their grandparents, etc. So if the school closes down in the weekends, people move to their second house. So there was a lot of hype and pictures on the journal, on the news in the evening, about people from Madrid who fled all to their beach houses, and the risk was that it was overcrowded. They were overcrowding the health services there, and they would collapse the intensive care units. And there was even some kind of hate against people who moved to the second houses. And when we looked in the data for those specific days and between specific areas, we didn't see any spike in those things. And that means, so we have anonymized aggregated data. So we don't see everything, because small groups are filtered out. Everything below 15 or 20, you don't see. But so if they found this, then it was more an anecdotal thing than rather a common thing everywhere. And actually, we got a lot of requests from the local governments of those areas, but please tell us, we are afraid, we are afraid that our hospitals are being overbooked, but it didn't actually happen.
Yeah, that's really interesting, because we had similar suspicions in the UK, but as far as I'm aware, we haven't seen any data one way or the other, whether people really did all go to Wales or Cornwall or the Lake District, or whether it was just rumor.
Yeah, so we have now in Spain, we have some new outbreaks, and they are all popularly associated to young people who have partying in the night, yeah, in the evening. But of course, those are relatively small groups which we cannot see in our data. Yeah? But probably there are other methods to find out whether this is really true or not.
Thanks, Alex. Thanks, Richard. Alex, anything else?
No, I was just saying thank you.
Lovely. Thank you so much. Jack Norton, are you there? Do you want to ask a question?
Oh, yes. Good afternoon. Yes, apologies. It was to Shraddha. It was just, I apologize. I've just joined in from the breakout session, so I may have missed something that I'm, I'm not getting. I just jumped in where you were showing a single AI that could play multiple games at the same time. And I kind of get why it would be really cool to have a single AI which can play any game you give it. But I don't understand why it's interesting that it could play them at the same time. So I'm assuming these games aren't related to one another. Because what happens in one game doesn't affect what happens in another. So what's the benefit of having one single AI that's playing them all at the same time over having just a different AI playing every game?
No, that's a very interesting question, and also has roots in like the way we theoretically see AI. But to kind of get a real world parallel in there, what we actually want in context of AI, especially when we in the future want to talk about general artificial intelligence and whatnot, is this one vessel which can learn any task. Now imagine you have a bunch of tasks at home. Let's say you have to kind of cook some food, like cook a pizza. Another one is to wash some laundry. And another one is basically, I don't know, clean the house. For all these three tasks, we are kind of in context of artificial general intelligence. As a human, you always know that you can take the same human, teach him how to do this task, and the human will always figure out how to kind of do this task well. It depends on how well you teach him, or how motivated this person human is. He will eventually end up doing all these tasks over and over again. So this is just one empty skeleton which has the ability to learn to do a whole lot of things, even if these things are completely different. But many of these things might have a bunch of things which are common. For example, to be able to cook, to be able to clean, and to be able to do the laundry, you need mobility of your own body. You need to know how to navigate, how to plan, and whatnot. So while doing one task, you're also partially solving some high-level task of the other task. So if we can demonstrate that the same empty skeleton, empty black box template can actually go in and solve any series of tasks that you can give it, then you are demonstrating that this learning strategy that you have can actually scale up to a whole variety of real world things, which will actually, the thing will be faced when we actually deploy it ever out in the society. Does that answer your question?
Yeah, no, that does that. Thank you very much. So like if you had an AI, really simple example, if you had it try and learn to play Super Mario and Super Mario World at the same time, it might actually learn to play those games quicker than if it was just playing a single one in isolation because they're related. Yeah, that's a cool idea. I like that. Thank you for explaining that.
And there's another catch there too, because traditionally when you talked about AI, like about go back 15 years from now and others, where many of the bots that you would see for many of these games, Counter-Strike, AI and others, were a bunch of rules. So even right now, when you're playing many of these big games, the bots and the AI that's actually sold in there or pitched in there are just thousands and thousands of handcrafted rules. It takes months and years to build those rules. And in a setup like this, when you are kind of coming up with this, spending months to kind of come up with this set of rules to play, say, Super Mario, and suddenly you change the game, then do you have to sit down and invest to kind of write the set of rules for another game, let's say Angry Bird or whatnot? But if we actually give it a whole variety of games, and in some of the games, the actual, the programmer, the engineer who's designing the AI never even gets to see the actual games the AI will play, then it becomes a lot more interesting. Then the engineer, AI and researcher will have to push for how to kind of build these templates which can learn from experience and truly learn without giving these hacks and shortcuts that we give in context of rules.
Yeah, like how when a human plays a game, they obviously, I know how to play a generic platform game because I've played Mario before. Yeah, I like that. Anyway, thank you. I'll let other people speak.
Thanks, Jack. Thanks, Mahanti. Paul, are you there? Do you want to ask your question?
Yes, I mean, it's a question for any of the panel, but maybe Christoph might want to start. But it's really something I've been fascinated for a while, that when you take AI as a starting point, clearly a lot of innovators are starting with the point of the human form, the humanoid form, and they anthropomorphize. So they create stories around, we can make the house faster, we can play a game better. And the starting point is the human. Others have, particularly imagined the starting point of AI of being an alien form. It doesn't need to follow the dumb behavior and the kind of limited form of the human being. And then we end up with kind of alien forms of AI that can parallel process with 15 brains and 25 arms and so on. Do you think looking forward that I suppose it's a leading question really, but if our starting point is to anthropomorphize, the danger is that we just get AI to replicate what is already a problematic set of processes that the human being is kind of essentially weak?
Christoph, can you take that one?
Yeah, I mean, there are some people who say it was a mistake right from the start to see AI as something that would try to mimic a human intelligence, and we would rather be better off now changing our ideas fundamentally and look for some form of intelligence, but not something that tries to recreate human intelligence. So that I agree with that. I mean, on the other hand, at the moment, I think I do not see this as a very problematic question. I mean, we have so many problems with making AI not too dumb actually, and rather. So I don't see this as a rather relevant problem now, but I agree that we should not all the time in the future try to mimic human intelligence. Yeah.
Thank you.
I'll dive in with a quick one myself. Richard Benjamin's talking about predicting epidemics. We'd need a lot more collaboration, wouldn't we, on data? I mean, we had the data about COVID-19, but it took us months to trust it, act on it, verify it as not being fake news. Is it collaboration or something different that would create a faster, different outcome next time?
Well, I think first of all, it is a matter of digital transformation. Yeah, so this is governments who have to act on data. And in general, governments are lagging behind the commercial world. Yeah? So many large companies have gone through a digital transformation. They all have AI or big data departments, but it's only starting at the government level. So it's not institutionalized that they can work with this from the beginning. Yeah, they had a very steep learning curve, and they had to get a lot of external advice to make it happen. Yeah? So that's one of the problems why it took so long. And then as the same, I mean, the number of cases in the country, I mean, it is all aggregated. Yeah, depends of course on the country how much they are digitized. But for instance, in Spain, it goes from the hospitals to the cities, to the provinces, to the regions, and to the central government, and it's all manual. Yeah, so. That's why after the weekend, so on Monday, the numbers are always low. And then on Tuesday and Wednesday, they're a bit higher because they have to catch up from the weekend. And that reflects, so it's basically a matter of having a digital mindset, the digital capacities to deal with so much data and to act on it. It has to happen, but it will take some time.
Thank you. Thank you. There's open forum here. We've got a few more minutes for questions. Who else would like to contribute a question or a statement or an idea? Manji, why don't you tell us more? So we talked about simultaneously playing this idea of two different versions of Mario at the same time. Does that come into the question of AI being more diverse and AI's learning in different environments, different cultures, different situations?
Yeah, I think it's more about being AI being more diverse and also dynamic, where it can go in and adapt. The whole notion of something which can go in and adapt to a particular task is very important, because the whole notion of cooking is very different actually, because you can teach an AI how, let's say we have given the task of teaching an AI how to cook. So someone, let's say, gives it a set of instructions. The old school way would be, the classic systems way would be you give them a set of instructions. You have this robotic arm, you have to kind of, let's say, make pizza, you give it the whole recipe. But then at the same time, let's say this AI is being deployed in India, and now you have to cook a curry. Then the whole thing is completely different. The question is, can it adapt to a whole set of tasks and build upon the knowledge it had in a previous one, or it can independently learn both these tasks with equal efficiency. And there might be some tasks where it finds it where it struggles to learn about, some tasks it does not learn, but across a whole majority of tasks, it still has the ability to kind of learn this task without any expert hand-coded rules. That way, whenever you are presented with a new task in your setup, be it a humanitarian setup or a corporate setup, wherever you think AI can be used, you don't have to hire a large team who has to sit down and write rules. You just define the task, throw a lot of compute, come back after a few days or a week or a month, and you know this thing has learned how to do that task well.
Can I make one comment on this? Because I think it's important. I mean, this is all a data-driven AI, yeah, based on machine learning and learning from a lot of examples. But it's important to understand that those systems have no clue what they're doing. They don't know about cooking. They don't know about curry. They don't know about the ingredients. Yeah? They just have seen a lot of things, and they abstract and they learn patterns. Yeah, and that is the current state of AI. So it's very good at very specific tasks. Of course, you can try to extend it with transfer learning to other tasks, but they cannot reason. They have no common sense. Yeah, they have no notion of what they're doing. So we should be careful in not thinking that we can create today something that is closely to human intelligence. Yeah, even if that might not even be the goal. But I mean, we're still very far from that. And that's why it's also that machines, like especially deep learning machines, have a hard time in explaining what they do, because they don't do it the way people do. Yeah, so they can explain what they do, but we simply don't understand.
Well, that's exactly why we need to kind of challenge the research community with tough tasks like this, right? Give me one model which can learn how to kind of play in different games where some of them you haven't learned, but also this notion of reasoning, comprehension, common sense, and many other things. And the way we perceive it in the research community, it's also being challenged by much of the progress that has been done in say language modeling per se. Because until now, one of the running hypothesis right now is these models were very specific to a bunch of tasks and were not generalizing across a whole lot of tasks, because these models were too small given the amount of compute we had, the size and others. But recent results from language modeling tasks like GPT-3 and others, where you see this one large model is suddenly kind of solving a bunch of other tasks without any extra supervision or training, right? Where it has learned how to basically look at large piles of text and answer meaningfully some text, make coherent text, and the whole things, where the whole goal was to train a model which basically figures out what the next word would be, or how to fill in the blanks for a lot of sentences, but kind of have a human and make this human do billions and billions of fill in the blanks examples. And then suddenly this human has kind of learned this notion of a semantic relationship between concepts, how to do question answering, and many other zero-shot learning tasks. So we are kind of still getting there, but of course not to a point where a single AI can actually learn how to cook different things and other things. Those are still in science fiction. But in terms of theoretical results, these results from language modeling do show that we are getting much and much closer to this idea that the same model can solve many tasks.
Another question is whether GPT-3 understands what it says.
The question could also be a pushback. Do we understand? How do we answer these things? Because at the end of it, it's a bunch of these neurons firing each other.
Rich, I've just got to say that whilst you were dismissing AI, you were also calling it they. I just want to pull you up on that. Is that an answer for normalization? I don't know if Håkon is still there. I just wondered, and actually Christoph, do pick this one up if he's not. In the UK, we call our doctors GPs, general practitioners. Obviously, we note that they have this wide understanding across many different ailments and illnesses and health. Sounded like the conversation we're having there, really big opportunities in health where it can learn from many different domains rather than maybe what we see, which at the moment is quite narrow AI in health, trying to diagnose one problem in isolation. Håkon, have you got any thoughts on that?
Yeah, actually, I think that's all the capabilities of integrative medicine, I think that this is one of the most active areas of research. I think that's right now the area where you get one particular acquisition on radiologies, and then you go to a lab to get a blood test, and they don't share this kind of information because they belong to different services in a hospital. I think that AI has the capability to find ways to integrate these different parts of information. I think that's right now there is an effort, I have seen this in many different hospitals, of people gathering together and trying to get combine a task force, especially with the COVID-19, just to combine all these different information that's right now that has been kind of scattered around different services. So I think that this is going to be one of the most successful attacks on how to approach COVID-19 from the medical perspective, collecting and getting information from many different sources. I know different big companies such as Microsoft are attempting that, and many others. So I think that's the outcomes, and this is something that it's ongoing because this is all really recent. Is gonna be quite astonishing. That's how, if you get all this information from that has been scattered so far, has a really powerful predictive solution.
Thanks, Alcuin. Christoph, do you want to comment on that?
I don't think so.
We're very inclusive, and I'm just conscious that we maybe didn't get so much time with you on the Q&A, so that's fine. Richard, do you want to comment on that?
Yes, I think with the current state of AI, which is basically data-driven, database AI, we can still apply it to so many things that it hasn't been applied to. So I think maybe we touched only 10% of all the applications. So the potential impact of this technology that now is mature and it's getting even better and better, as we saw with this language model GPT-3. If you haven't seen it, it's impressive if you see what it can produce. It writes even tweets. It is true that you have to discard 40% of the output or more, but sometimes what it is amazing. And if you talk about healthcare, there is so much data that still can be used with the same technology and create enormous amount of wealth and opportunities for everybody. But this is not the end of AI. It's just the first important step. As I said, look at the child, a baby who gets born, knows nothing. In 18 months, it knows a lot of things. It has common sense, it has object permanence, it has causality, and AI doesn't have that yet. Why is that? It's a philosophical question, but we share a common reality. So even though we don't understand what's happening in our world, in our head, by looking at other people who do the same as us, we interpret that we have this common reality. Now, if it's only a machine, then it has a different reality. So maybe if you have different machines talking together, they might have a common reality and understand each other, but we will not understand anything, a clue about it. But then again, you have to go beyond just learning from data. You need to have common sense. You need to be able to reason, to infer things that are not there. We can infer things that are not there. We can do hundreds of things reasonably well. Maybe we can do 2 things very well. But an AI today does 1 thing very well, and that's it.
And maybe just I would like to follow up very briefly on that, because that again raises the question of guidelines for AI and ethical guidelines, as well as at some point we will certainly see regulation on AI. But for the moment, I think ethical guidelines is the most important way to go. And here I would like to follow up on the question also that was raised in the chat recently. I think this is something that many companies are recognizing, that you, and not just the big companies, but also small companies, also startups that come to us, for example, as an institute and ask us what should we do about the ethical side of machine learning, of AI. And how could we approach this? And I think this is something we need to work more on, and in a collaboration with academia, industry, and civil society. I think this is a very important important step to go. And for example, here at IAI, we are looking at how to structure this, actually, how to structure this kind of collaboration, and to put those necessary non-technical skills into development teams, for example, into the development process, because there's a demand for that. And I think this would be a great step to take, and how exactly to do that. That is something we would like to find out together with others.
Christoph, thank you. Thank you for taking us home. It is 6:59 here in the UK with the sun starting to set. We've certainly had the longest day of the year. That's well gone now, and the days are already getting shorter. Huge thank you to Hokwin, to Ali, to Richard, Christoph, Mahanti, and of course, Melissa, who was with us earlier on. But most of all, to you, to making this what it is. Thank you for those of us that have contributed and those that have joined, and everybody who's a part of this community.